All right, everybody. Video number 9, the combined gas law. Oh, it's combined gas law, not combines gas law. Silly me. The gas law relates temperature, pressure, and volume at different conditions. So when I change one set of parameters, what happens? Okay, this is going to be a big old plug and chug. Okay. Combined gas law calculations relate the before and after for sealed containers. So this picture's in your uh, packet, and you can see that I'm going to start off with 2 pistons, and I'm going to heat it. Heating it should increase the volume, increase the right, and then if I increase the pressure or decrease the pressure. So trying to just figure out. So these are just baseline. If I add heat, what happens to the pressure, right? And the other one is baseline, and then volume is decreased. So what's happening to the pressure, right? And the pressure, PVT. Okay. Anyways, I'm going to take these laws that I'm not going to teach you separately anymore and just put them into one big law, a table T. It's going to look like this. P1 V1 over T1 equals P2 V2 over T2. The P and the V are multiplied. It's pressure 1, volume 1, temperature 1. That is initial conditions equals pressure 2, volume 2, temperature 2, final conditions. 6 variables. You're going to get 5 of them in every problem, and you got to plug and chug. Remember, 1 is always the initial and 2 is always the final. That part is, I don't know if it's in your reference table or not. Here's the key, though. The temperature for this one is the one that has to be in kelvins. I haven't seen them make you convert to make it happen, but they could. So I want you to be prepared. Okay. Pressure and volume units may vary as long as they stay uniform. In other words, I don't need to be in atmospheres per se. If I am in atmospheres for initial conditions, I need to be in atmospheres in the final conditions. If my volume is in milliliters, then my volume has to be in milliliters also for my final volume. Okay, so they just have to jive. As long as they jive and the temperature's in Kelvin, we are all set. So let's do an example and you see what's up. So read this problem. A gas has a volume of 20 milliliters and a temperature of 298 Kelvin and a pressure of 101.3 kilopascals. What will the new volume be if the temperature is changed to 323 Kelvin and the pressure is changed to 50.65 kPa? So let's start with first the equation P1 V1 over T1 equals P2 V2 over T2. This is in the table T of your packet. And then here we go. Let's start plugging these things in. So the initial pressure was 101.3. Okay. And the initial volume was 20. And the initial temperature is 298. Okay. And then it says, what will the new volume be? There's the trick, the new volume. So this new pressure must be P2. Sorry, that went fast. And then new volume. What is the new volume? We're looking for that. So that's X. And the temperature change to 323. So that's the final. Change to refers to final. Okay, so that's 323. So now it's just a matter of plugging and chugging. At P1 V1 over T1, it's going to look something like P1 times V1 all over T1. Okay, equals P2 V2 over T2. Well, P2 is 50.65. I'm going to multiply that by X. And if you want to leave that as V2, you can. And I'm going to divide that all by 323. So now, because there's an equal sign, we cross multiply. And that is going to leave me, in my calculator, I'm going to say 101.3 times 20 times 323. I'm going to get a big old number. It's 654,398. And on the other side, that's going to equal 298 times 50.65x. And that comes out to be that 15,093.7. I'm going to divide both sides by 15,093.7, and I will get 43.4 as an answer. There is a fast way to do this mathematically. Remind me in class when we were starting to go over these on the board. I'll show you the super, super fast way to multiply by the reciprocal when I have x in the denominator. When I have x, I misspoke when I have x in the numerator like I did here. When I have x in the denominator, I have to go slow and plug and chug. Or I'm sorry, cross multiply. More coffee. Need more coffee. All right, but you can always go through and cross multiply. The thing that with cross multiplying is that when I do cross multiply this way and cross multiply this way, I then have to always divide out by the answer I get on the one side. So it makes it two steps. I'm going to teach you how to do it in one step in class. Let me know. We'll multiply by the reciprocal. All right, and with that, I think we are done. That's a unit, guys. So practice, practice, practice. If you need more practice on a particular subject, you come see me. I'll find you some problems. You can get some extra practice in. Okay?